Hello, my name is Jack Carter, and I've been working on an exploration platform for ranging sensor attacks on automotive systems in the 2023 Secure, Accessible, and Sustainable Transportation Research Experience for undergraduates at the University of Florida. Some short things about me. Again, my name is Jack Carter. I'm born and raised in Flint, Michigan, and I've traveled across the country to study at the University of Southern California. My major is in electrical and computer engineering, and my minor is currently in technical game art. I hope to graduate next May in 2024, and I have a ton of sports related interests, especially around Arsenal Football Club, Formula One, and I do run track and field for the University of Southern California. I also love to cook, and I love assembling computers. The focus of my lab this summer was on autonomous vehicles. A fully autonomous vehicle can rely on sensors and software to understand the world around it without relying on human interaction. And the market is shifting this way because studies have begun to suggest that over 90% of accidents derive from human error. So if we were able to remove humans from the driving equation, a lot of accidents could be prevented and the general safety on the road would increase. While we're a little far away from seeing mainstream use of fully driverless vehicles on the road, we do have some small scale examples such as Waymo One, which operates in Phoenix, Arizona, and in San Francisco, California, where they have a fully driverless taxi service. You may also see some features on cars such as Tesla's Autopilot or BMW's Driving Assistant Professional, which are mostly autonomous and can, for the most part, control the car's functions without any human interaction. However, even in normal cars, there are many autonomous features that have been around for decades, such as lane keep assist, adaptive cruise control, blind spot detection, emergency braking, and hands-free steering, to name a few. So how do these autonomous features work? Well, through sensors. An autonomous vehicle uses a number of sensors from radar to LiDAR to ultrasonic and even cameras to form a robust system of understanding and perceiving the world around it. Each of these sensors has their own pros and cons, but together they enable all the features we currently see on autonomous vehicles. However, they are not perfect. These sensors can be jammed or given false information. The source of this issue can be caused from something as innocuous as an adverse weather condition, but they can also be done by malicious attackers. That last part may make you feel a little uneasy, sound a little ominous, but the goal of the project that I worked on this summer is to help dispel that. The AutoHel exploration platform for ranging sensor attacks on automotive systems is meant to give everyday people a platform to explore and better understand the sensors of autonomous vehicles and understand what a malicious attack might look like. In our setup, we can observe the interference that two ultrasonic sensors can cause on one another and how that can be used maliciously. We have one on the victim vehicle, which parks a certain distance away from an object, and one on an attacking module, which can interfere with that vehicle, causing it to do things it's not supposed to. Throughout this experiment, the user will be interacting with a user interface and have a very simplistic approach and get feedback of how everything's working to better understand the system in play. Specifically, my work on the AutoHel project was mostly for the software, on both the back end and the front end. The back end is more the hardware level, where I was developing microcontroller code for both the attacker and vehicle modules, mostly done through Arduino. And on the front end, I developed a Python GUI, or graphical user interface, for the user to control. They could select settings for both the attacker and the vehicle and change different things such as the rotation of the attacker, the height of the attacker, the frequency of the sensor itself, the number of sensors they wanted to use, and on the vehicle they can control how far they want it to stop from an object, how fast they want it to move, etc. Across both the attacker and vehicle modules, there were a lot of different hardware level systems in play. On the attacker module, I developed code for the stepper motor and the servo motor, which controlled its rotation and height, as well as the ultrasonic sensor, LiDAR sensor, and end stop that were in control of other communication systems and start and end points. On the vehicle module, I was mostly in control of just the motor and the ultrasonic sensor that were controlling how far away the vehicle would stop from an object, as well as how fast it would move while doing so. One of the initial parameters my PhD mentor and I agreed on was to control the attacker and vehicle modules wirelessly. And this caused several problems along the way because the initial microcontroller that we were going to use, the Arduino Nano 33 IoT, does not support standard Bluetooth connection, which caused a lot of problems while trying to control it from our laptop. So, throughout a very strenuous 2 weeks, I went through about 5 different microcontrolling boards from an ESP8266 to a Arduino RP240 to the original 33 IoT to even a Raspberry Pi Pico W. Eventually, I got to the end and decided that a separate Bluetooth module would be the most intuitive and simplest solution to this problem, and that's what I did. And once that part came in, And I was able to establish a Bluetooth connection that we could send commands and receive feedback over. It was one of the most satisfying moments of this entire summer. As for the development of the front end and that graphical user interface, I used Python's tkinter library. And over the course of these 8.5 or 9 weeks of working on this project, I wrote nearly 2,000 lines of code between many different versions. As I was learning an entirely new library, I often had to use the help of my PhD mentors, who I'm extremely thankful for, in helping me get to a point where this interface is able to control the vehicle and attacker modules wirelessly. But my work is not done. The AutoHelp project is not finished. There is still some glue work needed to be done to make sure that all the software I develop will work in conjunction with each other, and there will also be alterations to the vehicle's carriage, in additions to both the Bluetooth modules and portable batteries to the attacker and to the vehicle. So as we progress from these initial prototypes, there will still be needed changes, which I hope to be a part of. There are so many thank yous that need to be said for my experience this summer, starting with Dr. Sandeep Ray. I'm extremely grateful he brought me on this summer, fairly last minute, and also encouraged me this entire time to always keep asking questions and to change the way I approach my problems. Also, thank you to Bhagawat and Raful as my PhD mentors. You have been fantastic in helping me address the problems we are hitting, despite us being around the world at different times throughout this summer. It has been fantastic to work with you. The entire Rising Lab has been incredible. Our lab events were a ton of fun that we did. I enjoyed playing charades with you guys earlier this summer. And even though many of the people in the lab weren't assigned to help me, you guys gave me a ton of insight into graduate school, into research, into industry life, into life in general, and I cannot be more thankful for that. An additional thank you needs to go to Mike Nazareth and Ashley Wilson for directing all the events for the SURF and REU program this summer. I've met some of the most amazing people of my entire life in these past few weeks, and I would never have had that opportunity without the events you organized, and they were just a ton of fun. So thank you to everyone listed, as well as just the University of Florida for organizing this summer and bringing on dozens of extremely talented and fun to be around people this summer. To anyone worried that this experience might be all work, no play, I can assure you there was a ton of fun things to do, and I'm extremely thankful for all the other undergraduate researchers here this summer who made my experience a one in a lifetime thing that I would not give up for the entire world. Whether it was going to the Space Center, going to Springs, going to Disney, going to St. Augustine, going tubing, this was a incredible experience, and I wouldn't have traded it for the world.